Hey guys, quick update on the Overflow cell build, the prototype. I've been drawing some diagrams for how the circuit will be laid out and selecting some components. Alright, let's take a look at the circuit. Just put these pieces back as a reminder as to what goes where. Okay, so this is the circuit. So we have a common negative going right across here. These are ammeters to let us know how much current is going through the 12 volt line and how much current is going through the 3.7 volt line. And you'll see that that negative ties up here. The idea here is that I want to use this point as a negative for everything, and I want all of this stuff here to be as close as possible physically. The reason for that is because I don't want any voltage difference in the ground from the Arduino to where it's measuring these voltages. The less of a voltage difference I can have there, the more accurate it can be in its reading. So that's why it's laid out this way. Excuse me. Voltage dividers to measure the voltage on each side, and then capacitors. This will be the inductor, and then over here we have a MOSFET that we will switch to charge the inductor for the boost, and then we have this MOSFET up here that we will use to buck the power back down. And so that's pretty much the whole circuit. I've picked out a few different components that I'm going to need, and so I'll show you those real quick. This is this is going to be the driver. An IR2101, which, let's see if I can show it on here. There it is. It's not going to focus. Anyway, it's an 8-pin. This will allow me to do low side and high side switching. However, in this diagram, you see this this is the low side output that controls one MOSFET, and this is the high side output that controls another MOSFET. And I forget what this is called, but basically we want this capacitor to have a little over 10 volts relative to this ground, not this ground. So if I measured this against the common ground across the whole thing, it would be the voltage of the 12 volt battery plus, say, 10 volts, so somewhere around 22 to 25. And usually I think this is used in a motor, and so this would come down and then collect power and then go back up. That's not going to happen because I'm not powering a motor. And so this is another piece. This is an isolated DC-DC converter. This is the B0512S-1W. So the 05 means that it will take in 5 volts, which is great because it's an Arduino, and it will put out 12 volts. But there's no physical connection between the pins. So that allows me to take 5 volts from the Arduino and then supply 12 volts to the high side for switching. And that's awesome. I'm actually going to use 2 of these little things. Reason being that I want to be able to have the low side switching work as well, and the IR2101 won't even turn on with less than 10 volts. So I'm going to need 12 volts there all the time. I could use the 12 volts from the 12 volt battery, but I'd like it to be able to work without being connected to the battery. Sounds weird, but that's how I want it. So anyway, the other component will be this N-channel MOSFET. I think this is the one. Anyway, that is what it is. So I'll go back to the desk right here. I've started trying to put some of these components together, and I have these little prototype boards for Arduino Unos, and I think I can build the whole thing on one tiny prototype board. And so here it is. There's nothing soldered right now. These are just kind of loose on there. But the idea is, let me grab a screwdriver and I can really point this out. So these two capacitors, just like we were saying down here, these two capacitors, here, let me try and get some better focus here. Well, sorry about the bad quality, but I guess that's what we have. Alright, so the common negative is going to come real close, and these two capacitors are actually joined. Maybe I can show you underneath. They're going to be joined right there so that the negatives are coming in, and then this will also this will also be connected to the ground of the Arduino, so it's measuring everything with this as the ground. And then this will be the 12 volt positive, and this will be the 3.7 volt positive. This MOSFET is this MOSFET, which is for the bucking, and then this MOSFET is this one, and that is for the boosting. This is the IR2101. There's a little ceramic capacitor right there, just so that it has the power it needs. I'll probably need to add one on the other side. And then the isolated DC-DC converters are probably going to be slipped down kind of into here. It's a little tight. Things keep popping out because I haven't soldered anything. So they'll probably go there, and then they'll provide power to this chip. And then right here we have the voltage dividers right by the caps for measuring the 12 volt and the 3.7 volt voltages. I don't have the ammeters on here. They'll probably have to be external. I just don't have enough room, but that's fine. I think it looks pretty good. And then I'll also need to put this fan right on top of here and connect that through a FET. Someone came in, so I got interrupted right there. I think that I was this fan being on here to help keep the to help cool it. And oh my gosh, everything's falling. And I'll also want to connect this temperature sensor to the heatsink. Maybe I'll just kind of throw that down there. I don't know if you can see that, but maybe I'll put that right there and poke it through, and then I'll get the temperature right in the middle of the heatsink, and that will be used to turn the fan on and off. And this is a 5 volt fan, so yeah, that's everything I've got so far. I want to solder everything onto the board, but I'd like to take a moment and think about it. So if any of you guys have any ideas on what I could do with this, if you like the design, if you think there's something that I should change, you know, it is a prototype, so if it blows up, then I guess it blows up, but hopefully it doesn't. Yeah, anyway, so leave comments, let me know what you think, and you know, stay posted for the soldering, which I don't know, it'll probably happen this weekend. I don't think I'm going to get to it before then, so cool. See you guys.